To meet environmental sustainability goals, the comprehensive treatment of residual end-of-life materials is a solution to prevent the release of potentially toxic elements into the atmosphere and to allow for the recovery of strategic finite resources. To align with environmental sustainability practices of today, a new or expanded strategy to the approach and treatment of residual end-of-life materials is necessary. Our focus today in Recovery 2.0 will be on the process of concentration and selective extraction, used for the recovery of individual elements from residual waste streams. Recovery 2.0 provides an opportunity to learn how to manage resources in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy, using thermal reduction. Typically, the methods of residue recovery rely on the concentration and selective extraction of one specific item at a time. Identification of the materials in your waste stream, which will contain varying quantities of a multitude of individual materials, is your first step in the concentration and selective extraction process. Modern technology allows us to identify each batch of materials in real time, enabling us to accurately characterize the elements contained within the residual wastes, in order to choose which target element to extract. There are many optional pathways or methods for the extraction process. These methods may include pyrometallurgical, wet chemical leaching, electrometallurgical or mechanical means. The extraction process used can be a combination of any or all of these methods. The target element being extracted may determine the choice of extraction method. Once the first item that you wish to extract is selected and removed, the remaining matrix of materials are identified and a new target is selected for extraction. The cycle is repeated until all the trace elements have been recovered. The overall efficiency of this process may be improved by consolidating fresh inputs of like materials at each stage. By consolidating residues with a similar matrix together, referred to as like materials, you can target your recovery efforts on specific elements on a priority or sequential basis. Typically, you would choose, or prioritize, elements with the most abundant concentration in your matrix. By targeting and extracting your first chosen element, you end up with a reduced total volume of leftover residual materials. The leftover residual materials from the previous step will have a newly calculated matrix or different mix and concentration of elements. This then becomes the feedstock for the second stage of extraction for your next chosen element. This method amplifies the concentration of all the remaining elements, which then allows you to repeat the process perpetually, ultimately recovering all the elements. In the past, we compressed the like materials into uniform shapes for ease of handling, storage, and sampling. This agglomeration process was referred to as cannonballing. Different groupings of cannonballs are accumulated based on the similar matrix of the elements contained. Once sufficient quantities of the like batches of materials are accumulated, we would proceed to refine and recover the next sequence or generation of the residuals. A balanced, or accordion approach, to refining and recovery provides multiple pathways or options and allows flexibility in the extraction choices in order to respond to current market conditions. There is a growing amount of complex multi-layer composite materials with trace metallic elements contained in modern waste streams. The concentration and selective extraction process achieves the recovery of all these mixed-up trace elements from the residual wastes. An example of a mixed composite waste stream that may be managed by using the concentration and selective extraction process is the isolation and production of an individual feedstock that resembles a complex synthetic ore. This synthetic ore, containing a blend of strategic critical, rare or precious residues, may be converted into the form of granulated residue nuggets. Historically, the typical legacy method of the treatment of heavy metal content in sludges and wastewater is to dilute, or reduce, the ppm content of the residual waste to a discharge-compliant level. The method of dilution, however, is not a solution to reducing the total quantity of undesirable elements of potentially toxic or hazardous heavy metals that may eventually accumulate in the environment. The alternative approach is the removal of the non-metal fractions, resulting in concentrating the balance of the materials into an enriched ore, as a feedstock for the recovery of strategic rare and precious heavy metal residues. In summary, adopting the concentration and selective extraction of residual materials may reduce the total volume of leftover materials from your waste stream. This process captures and harvests strategic finite resources, targeting and recovering primary elements. Of note, as you separate and segregate the residual materials into individual feedstocks, even though you may be able to technically recover the individual trace elements, there may not be large economical value to these products. In other words, it may cost you more to process than what you will get in return. If you are seeking more information about concentration and selective extraction, feel free to reach out to a core group of industry professionals. They can provide you with current data and answer any questions you may have. Recovery 2.0 was developed by Waste.net as a system to manage resources in a sustainable method by treating waste as a resource. If you would like more information about the Recovery 2.0 process, additional videos are available and links have been provided in the comments, or feel free to reach out to us. Waste.net is a tool to assist you by matching waste material generators directly with beneficial users of those materials. By connecting you with market participants, we foster collaboration and promote environmental sustainability. Visit our website waste.net today to learn more. Let us assist you in your efforts to manage your waste. Waste.net may also be able to assist you in finding a market to buy or sell your scrap waste or byproducts.